Hi again. So last time we left off with functions, specifically how to input things in functions and evaluate functions. Today we're going to do composite functions, and then I'll tack on a little thing at the end that doesn't have to do with composite functions. So last time I gave you two functions, and I called them f of x and g of x, and then I made up two functions, which I'll do again here. So this one will be 3x plus 2, and I'll make this one I'll make it 1/2 x. We'll keep this simple, so we'll just make it 1/2 x. So the other time, last time, I did something like f of 3 times g of 2, for example, and so you evaluated f of 3, then you evaluated g of 2, and then you multiplied the two results. Or I might have asked you to add the two results, or divide the two results, or subtract the two results. This time I'm doing something different with the two functions. This time I'm going to put one function inside the other. Put one function inside the other. And when I do that, it looks like this. So you see what I've done here. I've taken g of x and I've put it in place of the x in the f function. Now what does that mean? Think inside out. Think inside out. So we start from the inside. The inside is right here. So I'm going to put something into g, like I normally do, and then I'm going to evaluate g of x. But whatever I get when I evaluate g of x happens to be the input of the f of x function. So the output of g of x is the input of f of x. So think of two functions right next to each other. Here's g of x, here's f of x, and there's a conveyor belt. So I'm going to put some input into g of x, and then g of x is going to spit out some result. That result, we don't take it home, it's going to immediately be put inside f of x. And then what comes out is f of g of x. So these two machines are now interconnected. So here's an example. Again, I'm going to use these two functions. F of g of -4. So my first step is to do the inside. We do the inside first. G of -4. So -4 goes in my g function. I put -4 there, and that ends up being -2. So this will turn into f of the output of what I got for g of -4, which is -2. So that has replaced g of -4. I don't have to worry about g of x anymore. I just have to worry about f of -2. So now I put -2 in here, and that'll give me -4. Will it? Yes, -4. That's just a coincidence. That's just a coincidence. Okay, now I'm going to do it backwards. Not backwards, but I'm going to have f and g switch places now. I'm going to find g of f of Let's just do 2. Get rid of this. So now the inside is f of 2. So I'm going to first plug 2 into f of x, and I get 8. So this will turn into g of 8. And now I plug 8 into my g function, which gives me 4. Okay, so this is what a composite function is. It's taking two functions, or at least two functions, and putting one of them inside the other. There is an alternate way of writing this that some books use, and it's possible MathSpace will use this notation. F little circle G. Looks like fog, but F little circle G means the same thing as this. So the second one is the one on the inside. The one on the inside. It's not a dot, it's a little circle. Okay, so if you happen to see this notation, it's the same thing as this. Okay, so that's composite functions.